What technologies assess hidden dam damage and seepage? Imagine a dam silently showing signs of trouble deep beneath its surface. How do engineers find out what's happening inside without tearing it apart? That's where clever technology comes into play. Several advanced tools help detect hidden damage and seepage in dams, which is vital for preventing failures and disasters. First up are piezometers and relief wells. These are sensors placed inside the dam or its foundation to measure pore water pressure. When pressure readings go up, it signals water is seeping through or accumulating in areas that could weaken the structure. These sensors are simple but effective, giving early warnings of potential problems. Next is electrical resistivity tomography, or ERT. Think of it as a giant electrical map of the soil and rock beneath the dam. By sending small electrical currents through the ground, ERT measures how resistive the material is. Waterlogged zones or seepage channels change the electrical properties, making them stand out on the map. This method helps locate hidden seepage without digging or drilling. Then there are fiber optic temperature sensors, called distributed temperature sensing systems, and digital temperature cables. These are long, thin cables placed inside the dam or its foundation. Water seepage often causes temperature differences because water is usually cooler or warmer than the surrounding soil. These systems detect tiny temperature changes along the cable, revealing seepage paths over kilometers of the dam. They provide real-time, high-resolution data, making it easier to catch problems early. Infrared thermography is another powerful tool. It uses special cameras to detect surface temperature differences on the dam. When water leaks through the dam, it cools or heats the surface, creating thermal patterns that infrared cameras can see. This method is especially useful for earthen dams and can spot erosion caused by seepage even in hard-to-reach places. Optical fiber sensors with advanced analytics, like XCPT, combine high-resolution fiber optic cables with real-time data processing. These systems can detect very small changes in seepage flow, giving early signs of internal erosion or piping. This early detection can save lives and property by allowing quick repairs before failure occurs. Vadozone monitoring systems use sensors to track moisture, temperature, and water pressure in the unsaturated soil above the water table. Changes in these readings can indicate seepage starting to move through the dam's embankments, often before visible signs appear. Satellite-based remote sensing and artificial intelligence also play a role. Satellites capture images that show ground moisture, vegetation stress, or tiny land shifts. When combined with AI analysis, these images can identify areas where seepage might be happening, even over large or remote dam sites. Ground-penetrating radar uses electromagnetic waves to look inside the dam's structure. It can find internal channels or erosion pathways that are invisible from the surface. This technique is especially useful for earth and rock dams. Finally, new materials like self-healing concrete and smart materials are being developed. While they don't detect seepage directly, they can automatically seal microcracks that might cause water to seep through, reducing hidden damage risks. All these technologies often work together in a monitoring system. Sensors send continuous data to digital platforms, which analyze the information and send alerts if something unusual is detected. This combination helps engineers stay ahead of potential failures and keep dams safe for everyone.